Hello guys, this is the second lesson of the chapter 5 about rational function. What is rational function? Rational function is a function that can be expressed as a ratio of two polynomial function. Here, g of x and h of x, they both are polynomial function. So what about when the function is not rational? Look at here. When this function is not rational, you have three steps for determining the function whether it's rational or it's not rational. For not rational, if we have exponent of x or we have exponent with a fraction, this is not rational. Again, for example, if we have 2 to power x over x, so this is not rational. Or if we have x to power 1 over 4 or over x minus 1, this is not rational. What about square root? If you have a square root with a rational function, this is not rational. Look at this example. For example, if you have x over the square root of x minus 1, this is not rational again. What about absolute value? Absolute value, if we have the absolute value of x minus 1 over x, this is not rational again. So if you have these 3 points in our function, so this function is not rational. Let's solve these questions. This is all about your exercises. Determine whether each function is rational. Okay, now let's check. This is here we don't have the exponent with x or fraction, and also we don't have the square root or absolute value, so this is rational. Okay, what about this question? In this question, just look at here. We have an exponent with fraction. So this is one of these points that we have studied right now. This is not rational. Not rational. Question number 14. Again, here we have exponent with x. Look at here. Exponent with x. So this is not rational again. And this example, this is so clear. We have absolute value. We have absolute value, so this is not rational again. So you have to know all these points to determining the function is rational or is not rational. What about the domain of the rational function? Steps to finding the domain. Here we have 3 steps. If you know these 3 steps, you can find out the domain by an easy way. At the first, you have to find out the denominator, then equal to 0. What is denominator? Guys, if you have a fraction, the top of the fraction is called numerator. And the under of the fraction is called denominator. Okay, so at the first, to finding the domain of the rational function, just equal this denominator equal to 0. Then find out the value of x. Find out the value of x. After that, the domain is equal to real number, all real number, except the value of this x that we found it out the second step. This is really easy. Let's use it in this example. And don't forget, look at this note. Here we have whenever denominator is not equal to 0, denominator, it means here, is not equal to 0, thus the domain is equal to R. Okay? Now, let's try it on this example. In this example, find the domain, the question said, find the domain of this function, of this rational function. Okay, let's find out. At the first step, you have to find out the denominator at equal to 0. Where is denominator? This is called denominator. So x to power 2 plus 9x plus 20. This is denominator equal to 0. Then factor it. This is power 2, so you have to factor it, that we have studied at the previous lesson. How we can factor it this? By opening two brackets. Then here we have x square, right x, and x. Put down this, the first sign, and then first sign times the second sign, plus times plus is equal to plus. Then, here we have 20. How many numbers multiplied by each other is equal to 20? 1 times 20, then 4 times 5, and 20 times 1. Okay, so 2 times 10, sorry, 2 times 10. 2 times 10. But look at here, we have to add these two numbers, then equal to 9. 20 plus 1 is equal to 21. 2 times 10, 2 plus 10 is equal to 12. So just 4 plus 5 is equal to 9. So we have to use 4 times 5. 4 times 5 is equal to 20. Then by adding these two numbers, we will get 9. Then equal to 0. Okay. Then after that, you have to find out the value of x. The value of x, here we have x plus 4 is equal to 0. Then x is equal to, put this 4 to the other side of this equality. This is equal to minus 4. What about this one? X plus 5 is equal to 0. Then x is equal to, put this 5 to the other side of this equality. This is equal to x is equal to minus 5. So domain is equal to R except the value of x. Here we have two value of x, minus 4 and minus 5. This is the domain of this function. Okay, let's solve another example. Okay, it's really easy. Where is denominator? Denominator is here. This is denominator, x square plus 2x minus 3 equal to 0. Again, you have to factor it by opening two brackets. Okay, here we have x, where the first sign put down here, then the first sign times the second sign, plus times minus is equal to minus. Then what about 3? Just we have 3 times 1 is equal to 3. So 3 times 1 is equal to 3. Then we will write 3 times 1. Then by adding this 3, positive 3, and negative 1 is equal to positive 2. So positive 2 is here. So this is right. Equal to 0. Then find out the value of x. The value of x, here, x plus 3 is equal to 0. Then x is equal to minus 3. This is the first value. What about the second value? X minus 1 is equal to 0. X is equal to 1. This is the second value. What about the domain? Domain is equal to R, all real number, except the value of this x, minus 3, then 1. I hope it's clear for you all. This is about the domain. Just you have to know these steps. At the first, find out the denominator, then find the value of x. Domain is equal to all R, it means all real number except this value, the value of this x. Okay, this is about the domain and rationality of the function. What about here? Asymptotes of the rational function. Of rational function, we have two asymptotes. We have two kinds of asymptotes. The first type is called vertical asymptotes, and the second type is called horizontal asymptotes. how we can find out vertical asymptotes. We have this some steps to finding out the vertical asymptotes. The first step you have to simplify rational function. Okay, just you have to simplify the rational function, then find out the denominator and equal to 0, find out the value of x, then when you found out this value of x is called vertical asymptotes. Okay, it means first step simplify, second step find out the denominator, then equal to 0, find out the value of x. This is all about vertical asymptotes. What about horizontal asymptotes? For horizontal asymptotes, just you have to identify the highest degree. Don't forget this. For horizontals, just you have to identify the highest degree. If the highest degree of denominator is greater than numerator, then y is equal to 0. What about the numerator is greater than the highest degree of numerator is greater than denominator? So in this case, there is no horizontal asymptotes. If we have the equal degree, if it means the highest degree of numerator is equal to the highest degree of denominator, y is equal to m over n. What about m and n? What is m and n? M and n, they are coefficients of the highest degree. Okay, so let's solve this example about it. Example 1, and look at these steps. Identify all asymptotes of these functions. Okay, at the first, here we have y is equal to 2x over x squared minus 1. At the first, you have to simplify the rational function. We have studied this. Numerator is simplified, is simple, so you have to look at the denominator. Denominator is not simple, so let's write it again. Y is equal to 2x over x squared minus 1. It means you have to open two brackets, x plus 1 and x minus 1. Okay, so this is about simplifying. Then after this step, you have to find out the denominator and equal to 0. This x is equal to minus 1, and this x is equal to 1. Okay, when you equal to 0, then you can find out the value of x. The value of x is equal to minus 1 and plus 1. This is about vertical asymptotes. Let me write it nicely. Okay, this is vertical vertical asymptotes is equal to minus 1 and plus 1. What about the horizontal asymptotes? Horizontal asymptotes is equal to, here just identify the highest degree. The highest degree of denominator is 2 and the highest degree of numerator is 1. So denominator is greater than the numerator. So y, in this case, you have to say y is equal to 0. This is all about horizontal asymptotes and vertical asymptotes. Let's solve this question. Again, you have to simplify the this rational function. Okay, this f x is equal to x, then x squared minus 2x minus 3, you have to open two brackets, This is x squared, it means 1x here, and the second x here. The first sign put down here, then this sign times this sign, negative times negative is equal to positive. And for 3 you have to say 3 times 1, then you can check it, you'll get this polynomial. Let's equal to 0, x minus 1, sorry, plus 1 is equal to 0, then x is equal to minus 1. What about here? X minus 3, x minus 3 equal to 0, then x is equal to 3. This is called vertical asymptotes. What about horizontal asymptotes? For horizontal asymptote, just look at the original rational function. It means look at the highest degree. The highest degree of denominator is 2. Again, the highest degree of numerator is 1. So denominator is greater than numerator, then y horizontal asymptotes is equal to y equal to 0. Okay, this is all about asymptotes. Just you have to know these steps, then you will know how you can solve these questions. What about using asymptotes to graph? At the first, let me tell you about the graph of rational functions. For the rational function, if you have f(x) is equal to 1 over x, you have the graph like this. This is called vertical asymptotes, and this is called horizontal asymptotes. And what about 1 over x? 1 over x, it means like this. This graph never intersect these asymptotes. Okay, what about the negative one? For the negative one, if we have f(x) is equal to minus 1 over x, in this time, again we have this graph, and we have vertical asymptotes and horizontal asymptotes. And about the graph, it's vice versa. The graph is here and the another one is here. This is about the graph for asymptotes. So how we can solve these questions about it? The questions say graph y is equal to x plus 2 over x minus 2 showing all asymptotes. For drawing the graph for these kind of the questions, you have to just at the first you have to find out all asymptotes. It means horizontal asymptotes, then vertical asymptotes. The second time you have to put some points, take some points, then put it in the original function. Then you can draw in the graph for this function. So in this function, let's find out the vertical and horizontal asymptotes. At the first, here we have, you have to simplify, but this function is already simplified. Okay, so just find out the denominator and equal to 0. Then x is equal to 2. This is called vertical. And about the horizontal, because just look at here we have the highest degree of numerator is 1 and the highest degree of denominator is 1. So y is equal to where is the coefficient of these x? Coefficient of these x all 1. 1 over 1 is equal to 1. Okay, This is about what? This is about the horizontal and vertical asymptotes. Let's draw a graph. Okay, where is vertical? Vertical here, x is equal to 2. This is 1, 2. It means vertical, you have to draw like this. Let me draw it again. This is 2. This is vertical asymptotes. What about horizontal asymptotes? Horizontal asymptotes is equal to 1. So 1 is here. Horizontal, it means like that. Okay? So, for drawing a graph, look at here, for drawing a graph, we have to take 2 point greater and 2 point is less than these vertical asymptotes. Let's take it here. For example, this is here we have x and y. This is 2. 2 point greater than 2 is 3 and 4, and 2 point less than 2 is 1 and 0. Okay, now you have to put these numbers put it in the original function, it means here, to find out y. Okay, so if you put 0 here, this is equal to 2 over 2, positive 2 over negative 2, so this is equal to minus 1. Okay, if we put 1 here, it means let me write it for you like this. Okay, here we have, if we put 1 instead of x plus 2, then 1 minus 2, this is equal to 3 over minus 1. 3 over minus 1 is equal to minus 3. Okay, what about substituting this 3 instead of x? 3 plus 2, then 3 minus 2. This is equal to 3 plus 2 is 5, 3 minus 2 is 1. This is equal to 5. What about here? This time, if we substitute again 4 plus 2, then 4 minus 2, this is equal to 6 over 4 minus 2 is 2, then simplify, this is 1, this is 3. Okay, this is equal to 3 over 1 is equal to 3. Okay, let's put this point on the graph. If we have 0, if x is equal to 0, then y is equal to minus 1. Minus 1 is here. Okay, let's find out by this. Okay, if x is equal to 0, then y is equal to minus 1. This is minus 1. If x is equal to 1, then then y is equal to minus 3. This is 1, and y is equal to minus 3. This is minus 2, minus 3. It means here. This is here. If x is equal to 3, okay, this is 3, then y is equal to 5. It means here. If x is equal to 4, where is 4? Here. Then y is equal to 3. This is 1, 2, 3. So let's draw a graph. This is a graph. Okay, I know this graph is not this is not that nice, but it's okay. Just by taking more point, you can draw your graph nicely, and by detail you can draw it, but it's okay. And for solving this example, again, you have to find out all asymptotes. Okay, look at here. Just find out all asymptotes. At the first, we can simplify this. Just you have to find out the vertical by equal this denominator by 0, then x is equal to 3. This is vertical. What about horizontal? So we have the same highest degree, so y is equal to m over n. It means the coefficient of this x is equal to over the coefficient of the net of this x. It means 2 over 1 is equal to 2. This is horizontal. Okay, so let's draw the graph. And for drawing a graph, x is equal to 3, 1, 2, 3. Then y is equal to 2, 2, 1, 2. This is horizontal and vertical asymptotes. Then you can take some point 2 point greater than 3 and 2 point less than 3. Then let's do this. It's okay. Here we have x, y. Here we have 3, 2 point greater than 3, 4 and 5. 4, 5. And 2 point less than 3 is 2 and 1. If you put 4 in this function, 4 or 1, 2 plus 1 is equal to 1. 2 plus 1 is equal to 3, sorry. 3 over. Then 1 minus 3 is equal to minus 2. This is 3 over minus 2. 3 over minus 2. Then if we put this number 2 instead of this x, again we will get a number. Then we will find out this function is here. This function is here. Why? Because look at here, this x, before this x we have positive sign. So if we have the positive sign, it means our graph will be like this. But if we have minus this fraction, minus this rational function, it means our graph will be like this. Okay, so this is about today's lesson. I hope all is clear. If you have any question, you can send me a message.